Hey, Clemens. Hey, Clemens. Hey, Clemens. Good morning.
Hello.
How are you?
Good.
I know it's a little early for you.
No, it's fine. I was up at 4. I've been doing these projects for the Middle East, and it's
Oh,
been messing with my sleep schedule. So,
imagine. Can imagine.
I'm
Thanks for
like,
taking the
oh, well,
time.
I guess not.
Thanks for taking the time to do this. Appreciate it.
Yeah, no problem. This was something that I wanted to update anyway for the team. So I got in touch with kind of the with Ben, who runs a bunch of other stuff. Oh, why isn't this rendering? Wonder if
All right, I'm gonna let the hordes in.
cool.
Good.
Can I share my screen just to test?
Yeah, sure. Right. All right. That looks good. You see your tabs.
Yeah, that's okay. I can't seem to full screen, but I'm going to be switching between these anyway when I present, so I could show different sites.
All right, perfect. So, all right, I'm gonna start off with 4 or 5 minutes. I have a deck, like housekeeping stuff, and then I will transition to you.
Great.
Okay, great. Share my screen, and then I'm gonna get everybody in. Hi and good morning, everyone. We will be starting in about 30 seconds, just waiting for a few more people to jump on. Hi, okay, let's get started. Good morning from the East Coast to everyone else. It may be your morning or it may be your evening. We're glad you're spending the next hour or so with us. We've got a very exciting topic to cover today. And we've got one of the best people who can come in and talk about this topic here with us, Clemens, who I'll talk about in a short bit. What I want to do first is cover some housekeeping items and our upcoming events. I'm going to do that very, very quickly, and then I'll hand over the reins and control to Clemens, who's going to cover today's topic, which is a deep dive into Ethereum 2.0. I've got tons of questions, and I'm sure you all do too. So very excited about this topic. First things first, blockchain101.com. We just acquired the domain about a month ago. All of our events are listed there. So if you're ever wondering what's going on with Blockchain NYC, which is a little bit expanding beyond NYC now, be sure to head over to blockchain101.com. All our recordings for these sessions are typically available on Slack, but we are now moving all of those videos onto blockchain101.com, and they'll be there hopefully in a week, and going back probably about 3 months of sessions and content will be posted on blockchain101.com. So please be sure to check on that website frequently. If you're not part of the Slack group, here's our Slack link. The Slack group is education focused, is blockchain agnostic, and it's focused only on things that help the community learn. So there's no shilling allowed. There's no product sales services allowed on the Slack. So if you'd like to learn more about blockchain or different aspects of it, whether on the business or on the technical side, please join us on the Slack. Now we've got a bunch of courses and workshops and boot camps coming up. We've divided them into business track and technical track. On the business side, we've got Blockchain 101. A large number of people have contacted me saying, hey, they're coming into this space and they want to figure out what blockchain is. So we're doing a Blockchain 101 session. This is a session that I teach at Columbia Business School. I'm kind of fitting it into a few hours. So this is typically what other students pay thousands of dollars for. You can get it for free. It's going to be for about 3 hours. And then we're going to go into DeFi in the afternoon. So it's a completely independent session. We're going to do an introduction to DeFi. This will be somewhat quantitative. We'll cover how, for example, constant product formula works, what impermanence loss means, how does that work? And we'll look at how the different types of DeFi protocols and the different verticals, how they operate. And some of you may know that I'm writing a book for Columbia Press on DeFi. Hopefully it'll be out at the beginning of next year. It's a business reader, and I'm going to share some of the content that I put together in this course. And then in the late afternoon or early evening, we're going to do an NFT 101. This will be both theory and then a hands-on practical. We'll actually build an NFT and put it onto the Ethereum chain. So this will be both It won't be technical, but it will be enough for you to get familiar with how to do NFTs. So that's all going to happen October 16th, all in one day. It's going to be a busy day for me, but I think it's going to be fantastic learning if you're interested in that. Then we've partnered with the Crowdfunding Professional Association that wants to come in. They wanted to come in and do a talk. This is actually a course. It's a 3-hour course. There are going to be 3 instructors talking about how to raise $5 million for your startup. Right? In this case, it's for DeFi startup. And they're going to explain the laws and the rules and how you can do that using crowdfunding. Obviously, if you use tokens to do the crowdfunding, or you just go out and do equity crowdfunding, or even debt crowdfunding, where if you don't want to give up equity, that's an option. They're going to come in and explain how to do that. That's be on November 3rd. It's a 3-hour thing. We've got 3 instructors. I think one of them is an attorney, and they're going to explain the process and the due diligence that you need to do, and all of the pieces that you need to have ready in order to raise that money. Especially if you don't want to dilute your equity, this may be an interesting route. Then we have Nathan Windsor coming in to do a session on yield farming, explaining what yield farming is and how to actually do yield farming. He's actually going to show you how to stake some coins and earn some interest and how that works. And so if you're interested in getting into yield farming, that is one option. Obviously, yield farming is risky. There's rug pulls and all that. But if you stick with the major protocols, then maybe you can make a little money. And Nathan's going to come in and explain how he does yield farming, and hopefully we can learn a couple of new tools and techniques on doing that. Today we have the Future of Ethereum, which is a 5-part series. Today's is part 2, and part 3 and 4 are coming up. You'll see that shortly. Today's session will be conducted by Clemens. Then we have on the 21st, which will be a busy day for us. This is an excellent session. We have the head of risk management of Aave coming in, and she did this presentation at another for another group. I was there, I attended it. It was a fantastic presentation. I asked her to do it again for this community, and she agreed. This is some really, really useful information on how to look at protocols from a metrics point of view, from a risk metrics and liquidity point of view, what metrics matter. I think this is going to be an exciting session. This is more of a breakfast session. It's 8 a.m. And it'll go till 9 a.m. And we're going to have to close it off at 9 and let everybody get to work. But this is a great way to start the day, to learn about how to look at these major protocols, lending protocols like Aave. And then we have on the 25th, we have 2 sessions, 2 independent sessions on DAOs. The first one is what a DAO is, a DAO 101 and governance 101 primer. We have a person named Zeb coming in to teach that. And then we have the session after that, we have a couple of attorneys based in the UK that help you, if you wish, to structure a DAO and tie it down to some legal framework. So they're going to come in and explain how to do that. And we're looking for somebody to come in and do an explanation on how to do a Wyoming DAO. And we'll update you shortly once we have that individual in place. Then we have Stellar coming in on the 12th of October to do kind of high-level overview of what Stellar is and how it works and how you can possibly build things on Stellar. I really look forward to that. It's going to be pretty exciting. And then we have a primer on Celo. If you're not familiar with Celo, I'm assuming that's how you pronounce it, or Celo. This is something that you should take a look at. It is getting a lot of traction in the market. I'm not going to go into where they're winning. I'll leave you to Google that. But we have somebody from the Celo organization coming in and talking about their platform. Then we have a couple of different technical tracks. We have a blockchain analytics 101. We've got somebody that built an open source analytics framework that goes into different blockchains and pulls key data like mempool data and things like that. And he's going to come and explain what he built and how you can use it, whether you're thinking to do trading or staking or things like that, how it can provide you certain advantages. And so I think this is an exciting talk, which is also useful to non-technical people as well. If you're a trader or you're investing in these tokens, this might be an exciting or interesting talk. And then we have the last of our 5-part Solidity series, Hector Santana, who's been teaching this, been doing a fantastic job. We've getting very, very positive feedback. The last of that 5-part series will be, I believe, the Tuesday after next Tuesday. And then we will kickstart this series again, hopefully first quarter next year, because of the demand for this stuff. And then we have a course on how to use Brownie, which is the Python equivalent of Truffle. I'm not a big fan of JavaScript, but I've spent some time playing with Brownie, and I've done Python for some time, and I absolutely love Brownie. And I'm willing to share anybody. I created a kind of whole document, it's about 50 pages now, on how to use Brownie in Python. We'll be sharing this during this course, but we have somebody else coming in to teach the course. And so if you want to learn how to interact with the Ethereum blockchain or with smart contracts using Python, and maybe you're not a technical person and using Python is the way to go about it, this would be a great session for you to get involved. And then we're doing a 10-session thing that's going to span about 12 weeks, because it covers some holiday weeks, and you learn both blockchain and Python at the same time. So you learn some Python code, how to code in Python while using Python to build a blockchain or to inspect blockchain data. This is free. It's a 10-part thing. It's 10 sessions. There'll be 2 instructors leading this. So I really look forward to this as well. And then we're up to part 5 of our Open Zeppelin series. Open Zeppelins come in and explain how to do smart contract security. The last one was on attack vectors related to price oracles. I don't recall what the next session will cover, but we will announce that pretty soon. The videos for the first 4 sessions are on Slack right now, and we are moving them to blockchain101.com so that everybody can have access to them. And then we do have a Solana bootcamp. You know, Solana's been in the news this week, and that coin has been tanking a little bit, but we have them coming in and doing a bootcamp on how to build a dApp using Solana. Should be some very interesting stuff. Okay, and we have some conferences coming up. The biggest one is DeFiCon, which was the biggest DeFi conference last March. We're going to do a hybrid in New York. Just go to deficon.co to register. Right now, the RSVPs are free. They won't be free for too long. And we do have some big announcements regarding who's going to be coming in and speaking. We'll be making those announcements soon. Okay. And then the videos, if you want the videos for DeFiCon for March, we just put them up on a YouTube channel called The Science of DeFi. Just go to SciDeFi, and all of the videos are there. So you can see all these topics right now. If you wanted to look at, you know, hey, what is DYDX? How does it work? We have Antonio Giuliano come in and spoke about how it works in March, and we put that video up on YouTube. So that's a great resource for you to get your more deeper DeFi knowledge going. Okay, with that, I am going to hand over controls to Clemens. Sir, are you ready to go?
Sure.
Okay, great.
Absolutely. Let me share my screen. I am registering for some stuff for DeFiCon. You have so much going on. When do you sleep?
You're busy. Sleep. What's that?
Okay. Thank you, Jamil, for having me. I am Clemens Wan. I'm a global solution architect for Consensus. And today I'll be talking about ETH2, go through a fairly thorough deep dive of the history, the motivation, and the latest with the merge. And then I'll answer questions, and I'll try to run through this presentation. I can share it with you guys afterwards. So just as a, is this loading? Oh, here we go. Just as kind of an overview for those who don't know who Consensus is, it was founded by Joseph Lubin, who is a co-founder of Ethereum. And in 2014, 2015, building out the infrastructure products that you guys know, such as MetaMask, which currently has, I believe, 14 million monthly active users. as well as Truffle, which helps with your source control of applications. We have a diligence team that's done reviews of live smart contracts in Ethereum. Infura is your gateway. It is now connected to other layer twos as well as mainnet. So you can do an Ethereum API as well as Optimism, Arbitrum, Polygon, Palm, all that good stuff. We had acquired Quorum from JP Morgan last year, and now we have Consensus Quorum, which includes Go Quorum and Hyperledger Besu. And then we also have Codify, which is a set of products built as applications that are enterprise ready that deals with asset management and cap table management. So a lot of fun stuff that's happening at Consensus, and happy to talk more with people who want to build with our products or just use enterprise scaffolds, for example. So let's just get started with ETH 2.0. I'm going to give a bit of a disclaimer that this is just my opinion. I've been following the Ethereum space for a very long time. I started building applications when it first came out in 2015. And I started with building a syndicated loans application with Credit Suisse, where I was working. And then I had joined R3 for 2.5 years, building out the consortium, working with different financial institutions, informing them about different use cases, working on CBDCs. I was the tech lead for Project Jasper out of Bank of Canada, and then helped advise Project Ubin multiple phases out of Singapore. And so through my journey, and now I work at Consensus for the past 3 years, my latest focus has been on DeFi, NFTs, and now DAOs. And so a lot of big stuff coming out. Today, I will cover some pieces of ETH2 that I've learned and continue to help contribute to in my best abilities. It's just whatever's interesting. So ETH2 is obviously interesting and helps the rest of the community. So just a quick take from where we are. This is the Ethereum network. It is in demand. The network is changing rapidly, and there's a lot of different numbers. If you want to know the different areas that I look for data, I like the block.com right here, and I'll just share this in the chat. And you can see all the transaction utilization data, even the burn from EIP 1559. As well as CoinMarketCap in general. But if you just look through Etherscan, you can see most of these areas to see general usage. And we'll be going through some of these sites. I use Dune Analytics as well. But I think it got drawn on. The main thing here is it's being used. It's 6 years live. There's trillions of dollars in market cap, and it's come a long way since launch. And it's a constantly evolving ecosystem. You have the good, and then you have the bad. Bad things like transaction pricing being volatile. Spikes in transactions usually lead to expensive peaks in the network. I paid quite a bit of money to do swaps, and I probably spent more money on paying transaction fees than anything else, especially bridging between different networks. If we stopped sending transactions today, it probably would take 4 hours to drain all of the transactions that are pending right now. So it's not great. There is high utilization. And so therefore ETH2 as a solution will help with that scalability by reducing the network utilization. And of course, the ugly is the amount of power that's being used in proof of work. So 48 terabytes is huge use of power. I think it's somewhere like I guess the size of Uzbekistan in terms of usage and consumption. So that's not great. There's a carbon footprint. We want to reduce that. And in order to scale and become sustainable, I think this is the two things that we've been focusing on and thinking about. And estimates may vary, but somewhere between 2,000 and 10,000 times more power efficient to move to proof of stake. So that's where we're heading towards, as well as parallel computation. So, blockchains are single threaded. The scalability plan is to use shards. We're going to deliver both while maintaining our core, decentralization, permissionless, resilience with live networks, being correct at all times. So this is our main principles and the high level goals of ETH2. Ethereum has been in a trajectory for proof of stake since 2014. Actually, Vitalik talked about it very, very early on. The energy consumption is obviously much lower by comparison. And also finality is a feature for proof of stake. So there's probabilistic finality with proof of work because different miners can choose which chains to provide as, you can do a 51% attack on it. Proof of stake is kind of known time based on randomization of who's going to submit the next block. So every 12 seconds will be a new block automatically. And so the only metric where proof of work wins is that it is much simpler. There's probably 100 times more lines of code in proof of stake to implement it. But in my opinion, the advantages obviously outweigh the disadvantage of power consumption. Just a bit of history, and it might help with, maybe helping people think through what's happening with the merge. The historic plan, and this might be your current mental model today, is that it used to look like, oh, we're going to have the proof of work chain running with proof of stake and beacon chain in parallel. And so beacon chain is what we like to call proof of stake. It's a contract that exists that will become the beacon in the future. And so it's currently has ETH staking into it. I'll add more about that later. And then in this type of journey, we would go in kind of the linear form to demonstrate that it works, then add some sharding to it, and then add the execution layer, and then bring over proof of stake and turn off proof of work. And so that was kind of the idea, is to have like a super highway that's being built next to a regular, dirt road, and then traffic would be moved over. And it's very linear, phase 0, 1, and 2, which would have been great. And the idea, just from a different view, is that you would have these existing ETH1 chains producing blocks with proof of work. And then you have this loosely coupled, set of ETH2 beacon chain deposit contract where data is basically added, and that there's no real connection right now for beacon chain and proof of work. It's just kind of a contract living there. And then eventually you would add some sharding, originally at the thousands, but now it's looking at 64 or so shards. And then from there, we would think about adding in WASM or using lazy execution or other functional languages to turn off proof of work, import proof of work, and state change into the model. And that was the original plan, right? To turn off proof of work. And now we've changed the roadmap because there are new factors in play. So what prompted this? There was an increase of urgency. Originally, proof of work was going to run for 2 to 4 years, right? But now there's so much more pressure to turn it off. EIP 1559 has been helpful for creating a deflationary currency. I think right now with proof of work, we're paying too much for security, and there's a need to compensate miners for electricity that they're burning, right? And we need to do this cheaper, and proof of stake provides that without compromising the security. So the urgency is to turn off proof of work. The second is scalability. There's a lot of new paradigms that have come into play. Where sharding and executable shards for layer 1 are not as important than just using rollups. So a little more than a year ago, I think Vitalik wrote a lot about rollup centric roadmap, which is outside of the main protocol. And this actually relieves a lot of pressure from layer 1 protocol devs to say that other things can be done in a layer 2 way for scaling. And so it's really kind of short-circuiting the sharding priorities and using data sharding in rollups to complement this for now. So where are we today, and what does the new plan look like? We are more or less at this, orange point today, where the merge is hopefully going to happen early next year, or at least by mid next year. The milestone of the merge is to turn off proof of work and turn on proof of stake. And so the beacon chain launched in December of 2020, and it's been doing fine. We can go through stats of that a little bit later. Then we'll, after that, implement data sharding, and then we'll merge the system as ETH2. Or ETH2 will then be called just Ethereum because it's the two chains merging together. It's not two separate chains that, we're not abandoning ETH1. ETH1 will become a shard of the consensus layer, which I'll talk about. I have a bunch of slides on that. So here we are today. It looks a lot like that other diagram. And the links to proof of work chain is just by watching the contract. Next is the merge. And so you turn off proof of work and then put in proof of stake. And then after that, you are talking about, turning on the shards where everything can run on the same execution layer. And then proof of stake comes first, and then shards will not be, executable in there. Just kind of a quick digression about rollups. I'm not going to go too deep into this. Plenty of presentations about rollups. You can think of it as a commit chain, where you're committing some of the values, if not all the values. On the left right now, you see a monolithic regular, ETH1 set. So this is split by data, execution, and state. And it's transaction to blocks, right? Single execution engine with the EVM. Every code needs to be managed. In order to scale that, we have to parallelize. And so L2 or layer 2 is basically I can't say it, parallelization, where you do your state and execution within the rollups, and then you save that data onto mainnet. And so I believe Ethereum will have around 2 megabytes per second of data availability, and the amount of data that's on chain can increase by around 500 times. So the computing is managed outside with the rollups, and then the data is saved and committed to the mainnet chain. Second is the blocks and shards with data parallelization. And I think that the security model that zero knowledge or optimistic rollups inherits is great for the beacon chain. And I'm sure, whole presentations I've done, I can share a link to different talks at EdCon and other types of conferences more recently about rollups. Okay, so let me just go very, very quickly about beacon chain, because I think it's important to think about and learn. This is the new version of the roadmap, and consensus layer is the beacon chain itself. And so ETH1 becomes the execution layer. And let's see what that looks like. The beacon chain right now has 238,000 active validators that's managing the chain. And that's with 7.6 million ETH that's locked up. So all of this ETH is locked up here with an average balance of 33 ETH. And so that's because they've been earning rewards this whole time. So they've earned an extra ETH for being in this contract for almost a year. Onboarding new ones all the time, right? At our current prices, it's a lot of security on chain, and it doesn't really do anything, but it's prepping for the merge. And why do people stake with ETH2? It's to earn rewards. There's no longer a block reward, right? In the future, I mean, there will be a block reward, but you basically get a minor reward by being a validator. And now, as you're a validator, you are voting. And so through your voting, you get a voting reward. So in aggregation today, you make about 5.6% APY, and the amount reward goes down for the more validators that you add. And so as we reach, around 10 million staked ETH, the bonding curve will go down to still around like 5%. So the gross return of staking your 32 ETH per year should at some point drop below the risk-free return rate that you can calculate, right? And that you can find elsewhere. And so people will exit this contract, and they'll find some equilibrium that we think is around the 10 million ETH stake mark, which is around 300,000 validators or so. That's more than we need, right? How do you stake? There are varying degrees of centralization and trustlessness that's associated with this. On the left-hand side is the most trustless and decentralized way to stake, right? You would have your own client, you could run Teku, you could run it on your own hardware, and then you can, be your own staker, right? You're responsible for your own keys. All of that is non-custodial. As you go towards the right, you get more centralized solutions. So you end up with a fully custodial model with an exchange where they keep all your keys and you trust that they'll stake it, as well as return your ETH at some stage later on. There are some subtleties for who owns which keys, but the point is that there's a spectrum available for users who want to stake, and you can explore these in different ways. So let's talk about the merge. So the next few diagrams are created by Danny Ryan, who is one of the core researchers at the Ethereum Foundation. He did a 20-minute presentation at EdCon talking about the merge. So I'll send that source as well. I think it's linked over here. When I share the slides, you should be able to click into it. Just to give you a high-level view, the blockchain itself is not surprising a chain of blocks, right? There's a linked list chain of blocks here where transactions are processed in the execution layer, and then consensus layer is basically, how do you reach agreement that this is the block for that execution layer? The execution layer is the storage of your transactions, and you're processing them off of the mempool, and then they get attested to by the members. The consensus layer around here is kind of what the miners and validators look at. They're agreeing upon the different process, and that's how you add this new block. And so needed that context just to show what we have right now, which is proof of work has its own execution layer, and then beacon chain, obviously proof of work is being done outside of the execution layer as the consensus mechanism. Beacon chain itself is a separate contract that is going to be proof of stake, and so this is published and it's running on the current network, right? And what does that look like in the actual merge? It actually just means that we're adding the EVM proof of work chain's execution layer into the beacon chain, and so you'll have execution clients like Geth, Besu, Parity as separate client software, but then you'll also have the existing consensus clients, or kind of the ETH2 clients like Teku, Lighthouse, Nimbus, and they'll all continue to run in parallel. So there's just going to be two clients. A client is here a node software, right? I'm running a node client that represents my ETH1 chain and then my ETH2 chain. Just a little bit more detail. This is just the high-level system architecture. On the left, there's mainnet ETH1 clients, right? And on the right, there's beacon chain ETH2 clients, and they run in parallel. Both of them come together and you turn off proof of work. That's the main idea. And beacon chain then runs all of ETH1's blocks and transactions. And so ETH1 client and ETH2 don't really interact today at all. They run in that parallel. And the only thing that the ETH2 client does is watch the deposit contract on ETH1 and waits to onboard new validators. That's it for now. On the left side, you'll see, they still gossip blocks. They discover each other. It uses a JSON RPC API. On the right side, it's switched over to a REST API, which is also validating. Because ETH2 has proof of stake, the actions are accountable. So we have the identity of the validators. You have to actually submit the identity of your hardware in your node. And so validators have keys and they're known. And so they will sign blocks and they'll vote. And if you behave badly, they will be punished by slashing. And so what does this look like in the next phase with the merge? It just means that we're trying to do something called a minimum viable merge, which means that we're trying to make so that almost nothing changes. And these are the actual practical changes that will happen. Number one, proof of work being turned off means all the ASICs are gone. So all that hardware that's taking up all that power is gone. We're also turning off the ETH gossip to look for the transaction mempools. And then the ETH1 side is added to beacon chain blocks, more or less. And so then ETH1 becomes the executable client, and ETH1 then the ETH2 then manages the stake. Hopefully that makes sense. Then an API gets added between both of them. You receive blocks now on the beacon chain, and then the execution client then adds the blocks into the chain. And so therefore you've kind of combined it all together. If you're running Geth today, for example, you'll still run Geth almost nothing will change. You'll have the same JSON RPC APIs, which is great. And then everything else is the same. If you're running an ETH2 client as well, nothing else changes. You have the same REST API and interfaces. And so we've designed this to be as transparent and non-disruptive as possible to existing dApps and tools out there. The maybe a little difference that I mentioned earlier is that instead of just having probabilistic finality, you'll get a block every 12 seconds with this new merge. So what has happened? Where are we? We had Ranism, which is a hackathon that was successful, which tested a bunch of test nets together in different combinations. So you see the consensus client and the execution clients were paired with each other and put together into different test nets. And it was really healthy. It was great working together with all of these different teams and combining this. The latest is with Altair, which is an upgrade coming next month. And so this is the first time there's an upgrade to Beacon Chain. We're using this as a test to make sure that we can upgrade the Beacon Chain, which is useful to do. There's not a lot of new functionality. The main one is just to test this network upgrade function, but it does add a light client support. It also creates bigger penalties for slashing, because when we first started, we knew that it was, basically a new thing, and we didn't want people to be overly slashed. But now that it's been running for almost a year, we're happy with the stability, and we're going to increase those penalties. So when is the merge? So this is just a summary. The merge is minus proof of work plus proof of stake, and that will be your execution layer upgrade. And for those who don't know, Ethereum is just your execution layer plus your consensus layer. There are a lot of people that are trying to put hard deadlines here, but this is not how kind of the Ethereum community works. It's fairly fluid. Everyone's working as hard as they can in parallel, and all protocols are looking at focusing on the merge itself. And we're coordinating across multiple protocol clients that have a lot of their own customers, and we're all working towards kind of the same thing. The gut feel, even Vitalik has said, and he's fairly optimistic, is kind of the first half of next year. And so in summary, no real big changes to the roadmap in the past 3 to 6 months, right? It's been fairly consistent. The Altair upgrade is due next month. The best estimate is early Q2 of next year. I would say withdrawals of stake and the staking that people have done on Beacon Chain are probably going to be available the next upgrade after the merge, which could be 4 to 6 months after. And so you'll have the merge, you'll see it come together, we'll turn off proof of work, and then to withdraw your stake of ETH, that will happen 4 to 6 months later. And then the data sharding research and prototyping is also going well, but I would say the roadmap for that is about a year to 18 months away. Meanwhile, rollups are going strong, and it's kind of supportive. I don't think that it's like ETH1 versus rollups. I think they come together as a part of Ethereum. Just a quick note, there was an awesome Reddit post thinking about where Ethereum will be in 2025 as a global settlement layer for different types of transactions and assets as well. This summarizes what I was talking about before, which is Ethereum in the middle has an execution layer, has a consensus layer, and has data shards. And once Ethereum leaves ETH2, becomes Ethereum again, you still have all of these other technologies that will connect to it. And I really like this diagram, because the more you look at it, the more you learn about all these different types of layer twos. And so, for example, here, Palladiums are a type of layer 2 that stores the data externally and then just saves their proof on the execution layer. Rollups, or kind of commit chains, does the same thing, except it also is able to do save transaction data. And so you can verify the actions that happen on your rollup layer. Volitions are super cool. That's the same thing, but with compressed transaction data that also references external data. And so volitions actually have some threat to other alternative layer ones. And I think it's a super awesome concept, and people have been developing with it. Examples of rollups would be Optimistic and ZK rollups. Those are Optimism and Arbitrum. Example of Volition would be like Immutable X. A lot of really cool stuff that's happening, and kind of a lot of great research there. Sidechains and Alt L1, sidechain being something like a plasma chain or Polygon in the Matic network. These are just running bridges, which means that they're doing some type of asset portability with wrap tokens. So I have to have a either trusted custodian or some REN VM relay bridge that allows you to transfer your tokens from a Matic, token in the Matic network to a Matic token in an Ethereum network. Those are two different tokens. And just kind of a quick note, Ethereum 2.0 happens a lot of consensus. We have a Pegasus is the old name, but internally we still call it Pegasus. It's our research protocol team of about 80 or so devs. We have the Teku product, which is our ETH2 client. We have Codify staking, which allows for parties and institutions to stake ETH. With the Beacon Chain contract, we have Infura, which now does real-time Beacon Chain data access as well. If you want to keep up with ETH2 news, definitely check out Ben Edgington, who made most of these slides and informed me this is his latest update that he sent out on September 10th. He's probably sending one out today as well. He does this weekly, and it has some updates. I can share that. Before I go any further, I just wanted to see if there are questions about the ETH2 public space, because I can either answer a bunch of questions, or if there's interest, I can go into how enterprises are using Ethereum. But let me just pause for a second.
Yeah, you do have a bunch of questions. You want me to read them to you? They're on the chat. Let me start from the top. First question from Kyle: is randomized validator section weighted by size of stake or entirely random across the 300,000 validators? The validator selection.
Oh, that's a good question. I think it is it weighted? I think it is weighted. I don't think it's not by, because every 32 ETH that's staked is essentially counts as one validator, even if you have it owned by multiple parties. And so it's pretty much an even selection across, but multiple parties can own one 32 stake validator.
Right. Okay. And then he's also asking, in the old roadmap, quote unquote old roadmap, you reference WASM, but in the new one you only mention EVM. So the EVM is going away, or so what's
I don't know exactly. I just know that WASM has been deprioritized because everyone's focusing on the merge. Who knows what's going to happen with that? I think Vitalik mentions WebAssembly being a superior language in different ways, being more compatible with kind of the internet altogether. But so far, we're sticking with the EVM for now. So I don't see anything in the next year roadmap covering WASM.
Right. Okay.
Question to get a chance.
Yeah, go ahead, Brian.
Now I'm very new at this, and I had a question about it. So, is someone that like for instance, if I sign up for Ethereum and I signed up for to have a stake, does that become a validator? So, how you become a validator? I guess that's my question. Because you mentioned
so it takes a few steps, and there are a lot of ways to do it, but the main step that everyone's doing in the back end, let me try to bring up that page over here, is that you have to first start a validator client. So you have to run a node like Teku, and then with that Teku client, you have to register your validator ID, because validators are connected to hardware as well as to software. And then from there, you have to move your staked ETH onto the contract and reference your client. And so what you're managing is the software of the client that is now holding your 32 ETH and submitting it as a stake as a validator. And so you would be officially a validator because you have two addresses. You have the address of your hardware that's holding that 32 ETH, as well as the there is also an address that's given to you when you become a staker, more or less. It's very, very complicated. I mean, I tried to do this and I kind of like blew away a lot of money running my own AWS version of Teku. And it was much easier to go through something like Codify staking, which people in consensus can use.
Right, and the 32 ETH is the requirement, right? Minimum.
Yeah. So it is a set amount that's required. There's pooling mechanisms that I haven't tried yet, and I don't really trust. We even talked about it within consensus. Can we pool 32 ETH and then try to figure out, separately who owns how much of the percent rewards? But that's basically done programmatically with these trustless pools. I just don't know, because the keys aren't yours and they're kind of like, the withdrawal keys are in the contract. It's kind of a little bit, I'm not a big fan of it.
So even with this non-custodial, the keys aren't yours?
The signing key is done by the Codify staking or whichever party, but you have your own withdrawal keys. So that's why I mentioned there's two addresses, two keys that are available. One is like directly impacting and directly connecting to the Beacon Chain contract, and the other is the validator specifically.
Got it. Okay.
Yeah, this is definitely advanced. Like most people just use an exchange like Kraken and say like, okay, well, help me get at least market exposure to it, and let me treat this as a perpetual bond that I can get, consistent savings on. Yeah,
maybe later, Clemens, you can drop resources like links to like where in the Slack where people can read up, like let's say the Teku docs, where they can read up how to set that up. At least maybe some people want to get familiar with it, with the process, maybe not even start the validator up themselves, but like know how one is started. And that might be useful. And we have another question here from Kunal. So not really clear on how the merger is going to work between what continues on ETH1 and what executes on ETH2.
So like a lot of slides that went through that.
What dies on ETH1 and what continues on ETH2?
Yeah, so specifically what's moving over is the execution layer is getting embedded into this is what's happening. Your execution layer is getting embedded into Beacon Chain. And so the ETH1 client still exists and it'll exist as a shard, while the Beacon Chain becomes, basically ETH1 will be the first shard inside of a data sharded ecosystem. And this is all happening kind of with the same set of computers, right? So Beacon Chain is right now the contract that will help with the consensus piece of keeping track of all the transactions. Does that make sense? If you want to unmute and ask, that's probably
Kunal, if you want to unmute and ask that question or follow up. Okay, I mean,
yeah, no, it's fine. I think we're going, we're covering a lot of material, so I didn't exactly.
Oh, okay, that was an old question.
Yeah.
No problem.
Can I ask a question if you have time?
Yeah, go ahead, please. Yeah, go ahead.
Thank you, Jamil and Clemens. This is a great presentation. I'm just curious about the L2 solutions. How there are a couple of L2 solutions which are similar to each other, and I just wanted to understand how they're integrated, because it sounds a bit like there are a couple of solutions that are working for the same type of solution, but I didn't understand how they're going to be integrated. That was a page that, the previous, yes, this one, for example, validiums and rollups. I understand their functioning, how they're functioning, but I just want to understand how they're going to be integrated.
Yeah, integrated in which way? I mean, integrated as in like cross rollup conversations and asset portability between rollups, or what do you mean by integrated?
in terms of scalability, because, for example, the validiums are working for the data availability, right?
Mhm.
So
Because they
the
have external data confirmation. Yeah.
external data. So rollups will be the similar function as well. Isn't it?
I'm still confused about the question. I could describe rollups and commit chains and different types of rollups. And just kind of very quickly, a rollup is a separate network with a separate set of operators that are created and referenced on the Ethereum mainnet. And so there are smart contracts that initialize your rollup network. And that network uses, let's just go with zero knowledge proofs for ZK rollups. The zero knowledge portion is the way for you to, so in finance, for example, you have netting and you have kind of this large value transfer settlement. And so for that to occur, you need to batch a bunch of transactions together. So I think about rollups as a separate network with trusted operators that are batching transactions into a anchor to mainnet. And so all of the execution and all of the work, the reason why the zero knowledge is needed is that the execution layer needs to prove that the rollups and all of the transactions within the rollup was done properly and was executed properly. And then it has to save that data and compute that data so that it could be saved on the mainnet. So your L1 is basically confirming and settling. And so if you think about it like a bank, the L1 would be like the CSD plus the Federal Reserve that's kind of confirming all the transactions. And then the rollups would be like separate banks that are dealing with their own separate transactions with their customers. So it's kind of a commitment from trusted entities. Does that make sense?
Yes, yes.
So integration means that there's likely between rollups and between shards, and you can treat a rollup as a shard as well. The data sharding plus like the computation is removed so that you don't have to pay the high gas fees and you don't have to wait for those 12-second blocks. Rollups can be a lot faster because they can be special purpose, or it's just a separate network that uses the security of layer one by saying, hey, the Federal Reserve is keeping track of all of this settlement. But in terms of computation and other types of things, they can optimize it for layer two.
All right, thank you.
Yeah, that was a great answer, Clemens. So so I think there needs to be some clarification between ZK, optimistic, rollups. Do you have some slides on that you could share, or talk about that quickly? Because there's some fundamental information that I think we might assume about the audience that may not be true, right? They might not know certain things. And I think maybe if you have some slides around that to kind of clarify the differences between.
I don't know if I have one right now. There's just the simple portion is that optimistic doesn't require that same level of zero knowledge because it is basically trusting that the parties will accept it. It's an optimistic look at accepting the set of data that was committed. And I do have, maybe it'd take me a second to look it up. Give me 1 second. We did this presentation on rollups and different types of rollups, and maybe that could be useful. There's a visualization of the operators and how it connects. 1 second. Any other questions that I can answer? Everyone feels like proof of work is
Right, there's a
secure.
little bit of a debate going on in the chats right now about proof of work and proof of stake. I'm going to avoid that debate for now. But yeah, the other questions from Tom Cooksey is asking, will we be talking about rollups at all in depth, ZK versus optimistic, etc.?
That's a completely separate presentation altogether. But I would say that this is probably easiest way to look at your rollup, there is a separate set of states, obviously, and there are separate transactions that happen on the state. And some of the complexity that is sometimes included or removed is based on whether or not you're doing this EVM and EVM execution, which means that the transactions that occur on your rollup have to time shift and also get confirmed with your layer one. And so when you're doing full computation on both sides, as in like matching up the executables on both sides, it will require execution manager smart contract that basically makes a virtualization of an EVM in order for the EVM to understand it. So essentially there's a set of instructions that doesn't allow for that off syncs these two because you're doing this time commit, and those have to be updated. And there's code that basically does this time shifting. But the thing that I was talking about, kind of this roll-up architecture, is that your operator network is formed with layer one in mind. The staking is done by the operators and the roll-up VM is established. The users both work with the operator network as well as deposit into your layer one contracts. And then when any type of activity occurs operationally, transactions being sent to the operators will continue to get some type of staking reward for the operators, but then you can also challenge and withdraw from the roll-up VMs. So it's a little complicated, but basically the roll-up VM is what's a little bit different depending on the type of roll-up and maybe even the staking mechanisms. But different companies are trying different variations of this type of architecture, which is just operators in the middle, user accounts that match both layer one and kind of this new network, and then a batching of transactions for leveraging layer one for its security, more or less. Does that make sense? I think it's hard to visualize, especially if you're kind of just learning about Ethereum in the beginning.
Well, Tom, there's a video from the VP of growth of Polygon that did a breakdown, did a fantastic breakdown of the difference between the different approaches. Cool. And that video is in the Video Lib channel on Slack. So I highly recommend you watch that. I think that was the main focus of his talk, was what are the differences between those approaches. And then to Clemens' point, like to do a deep dive into that probably take 3 hours or more. And so maybe we should do that at some point in the future. We should have a session on that. And maybe Ben can come in and do that, Clemens, if you think that makes sense.
Sure. Actually, we have a roll-up solution within Consensus, and we've implemented it for our CBDC projects, which is why we have like these comparisons with Consensus roll-ups. And we do it for permission network, but we also have like GNARCs. We have our own libraries that we've created, and we have a research team that has done and built this roll-up solution. So we might launch this into the public, but so far we've just been doing it for our private CBDC experimentations. But high level, it's really depending on who you trust as well as what type of proofs are being committed or kind of disputed.
Got it.
Cool. I am
you want to
conscious
continue?
of time. Is there any? I mean, I can continue. I have other slides that I've done. I was a keynote speaker at EdCon as well, and I covered some pieces around enterprise usage of Ethereum. But if it's out of scope, and happy to cut it here.
Yeah. Okay. I mean, if we have any more questions. Yeah, quick question for you, Clemens. So on the staking side for validators, so as the return rate goes down and approaches, let's say, the risk-free rate of a T-bill, and even lower, then the theory is
like
that
5% or so, maybe.
Right. Yeah. So but the theory is that that's where the equilibrium potentially could be, correct? What about the impact of the price of ETH itself? so theoretically, as the price of ETH goes up and up, the number of people that have 32 of them to stake goes down. Have you seen anything in relationship to sensitivity analysis around pricing of ETH and then the impact of that price of ETH on the number of validators?
So you're saying, will there continue to be steady growth if there is
Price goes up.
harder? So
Yeah.
I mentioned around 300,000 validators seems to be a good number. Likely what will happen is more and more institutions will provide offerings related to DeFi. I don't think DeFi is going away. I don't think Ethereum's going away. And the institutions that I've been working with have been thinking about how they can provide some type of consistent bond returns, yield returns. They're kind of just doing their own type of yield farming in their own way, but they don't have DeFi to do yield farming. They're just, looking for different ways to maintain their steady growth. And so my view is that institutions will first start with kind of B2B, providing staking on a higher level, maybe for crypto hedge funds, maybe for portfolio diversity, but eventually your fund itself will have within its index, either by price exposure or by actually doing the staking, to give some return that's variable, that is consistent. And I think ETH2 staking is a no-brainer because it is consistent and there's little risk. If you have this kind of as extra money, it's kind of like a CD, right? I've created a CD that I can withdraw in a year, more or less, and then I have consistent returns for it. It's variable, but with a fairly high percentage return. And I think more and more institutions will see that as a safe bet because it's already has that much locked up. Nothing to shy away from that. That's a lot of ETH.
Got it. Go ahead with your Ethereum for enterprise thing. I think there's a couple people interested in that. And then another 10 minutes and then we'll wrap up.
Yeah. No problem. Okay, so I could do this in 10 minutes. All right, so the journey that enterprises have taken is that we've built out these privacy layers on top of Ethereum, as well as permission and kind of these performance enhancements and all of these pieces, specifically because banks don't want to own crypto on their balance sheet, and therefore their interaction with the mainnet was prohibitive. And they essentially didn't want to deal with the security as well as the accounting and the treasury as well as the regulation. And so they sidestepped this by just saying, hey, I'm just going to create a permissioned network. And so our quorum networks that we've created are not supposed to have native crypto inside of its operations. To me, that really handicaps blockchains. If you remove any need for a native token, then you've also removed the incentive to run infrastructure. And so what the next few slides pitches for is a migration of permissioned or private networks over to public networks in terms of porting over their assets, in terms of bridging over the applications that they've written that's EVM compatible. And so this doesn't just apply to mainnet. This applies to all EVM compatible chains like Polygon, Arbitrum, Optimism. All of these are separate chains that you can republish your dApps to. And kind of what the advantages we're pitching here is not anti-consortium, but telling, very upfront that if your goal for a financial institution is to launch some type of marketplace around digital assets and be the owner of not just the application, but the network, there will be some issues with scaling that network up and bootstrapping the network to actually be recognized to have value. And so that's why all of the digital asset networks that we've created on Quorum, and there's quite a few dozen of them, they are running with just communication protocol upgrades between banks and not with, real value transfer that we see in the public network. So I'll go through a few of the slides that kind of express this. First is the lower total cost of ownership. When I was working at Credit Suisse, the bank way of thinking about things is, how many apps do I have and how much do they cost? And so when you compare a public to permission network, there's just an overwhelming amount of money spent towards building the actual network and supporting the network. And that's kind of like hiring database engineers, but in a very narrow space, right? Because protocol engineers do not want to do support. They've built a product, they've built the clients for the product, but it takes an entire community, entire ecosystem to support the public Ethereum network, for example. And so what this slide shows is, out of all these categories, the bottom ones exist for both the public and private network, but the top ones are different, I guess, barriers of entry that we faced when building out enterprise projects. And for example, the consortium formation usually takes about 6 to 12 months just to have all the business people agree on what to build. But this is before having a business case and fundraising. And so they are all pitching to their own banks saying, hey, I need to invest money into this new tech venture, and we're going to do a venture across 10 different consortium members, and we're going to raise money to support the tech team in order to use this application that we think is going to be profitable and think it's going to be great. And at the end of the day, yes, they're able to raise small amounts of money, but whatever you hobble together is basically being burned into all of this other network running stuff. And why do that when the actual public network is available? And yes, you may have to purchase crypto and figure out ways to actually pay for gas costs and transaction costs. But that's almost like, hey, let's go back before there was cloud and start running our own applications between each other, as a layer on top of cloud, rather than just using the cloud for compartmentalization, for scaling, for all these other great services. And so my view is that Web3 is only useful if there is tokenomics, and without tokenomics, you've kind of just reduced it to a shared or distributed database. And so keep this in mind as the volatility and the regulations. And I think that still is the hesitancy for people to move forward. But the journey that we present to the enterprises is to start off with a permission network, deploy applications that are deployed open source and with smart contracts, and we hand out full libraries of science projects that people can do inside of their banks, and then they start thinking about the real business model, which is, what is the token play, what's the DeFi play, what's the digital asset liquidity play in the mainnet world, and how can we create a diversified product that includes all of these different projects, right? A combination of projects. What does that composability mean? So the replication is also a big part of this, right? 15,000 nodes that are independently owned, and maybe they're part of pools, but at least the full nodes that run are doing full replication of data. And therefore, if you change your node, you're basically with the gossip of your peers, likely going to be corrected to kind of the agreement, the consensus of what the data looks like. In a private network, there's so much private data included that the weakest node becomes the weakest link, and therefore most parties usually put together a enterprise package that is noted as kind of the base amount of security, as well as base amount of features that are needed to be a healthy node. And so for the Corda space, for example, it's Corda Enterprise, where Corda Enterprise applications have to run on Corda Enterprise node types. And that becomes another barrier to entry, because now you're asking people to pay $1 million to run a Corda Enterprise node, for example. And so, my view is, in that case, you might as well think about Bloomberg and Bloomberg terminals. If Bloomberg is able to build an app store, and they did back in 2012 because I made an application for it, and we tried to sell it to other people with Bloomberg terminals, and they didn't buy it because, hey, why would I buy an application built by another bank? So I have a dependency on another bank for IT. And so the model is great, but there are shortcomings to selling different applications. And so, the reason why I left R3 from building core apps to building, Solidity smart contracts and building dApps is because I thought that sales model was just a little bit missing. The journey was too long. Okay. So yeah, I'm not pitching permission. I'm actually pitching public. And one of the bigger reasons why is crypto market infrastructure. And so I'm a firm believer that, when you create this market infrastructure, it's actually much more important for liquidity and for value than just creating a shared protocol. So these are big players that actually bring value to networks. And I've written about how to bootstrap a network. And so, yes, these are attached to the presentation. And I've done this presentation at Counter as well, so I can attach that. And the providers of this technology are more or less, they're more or less available and have supported these protocols fully and have built B2B strategies and have committed depth in their order books in order for it to be profitable, and in order for there to be ARB opportunities for large institutions to actually make a play, right? If it were just a single network owned by 10 banks, it's powerful because they can commit their collateral, but all the collateral they commit is essentially on an island, and it's not connected to any of their settling and clearing systems that are recognized by the legal entities, and therefore it can't be used really. And so any new network that tries to create this type of crypto network in parallel, and this includes CBDCs, and I've built quite a few of these CBDC concepts as depository receipts that you have to redeem back, so you don't have to deal with interest that's collected. We did cross-border CBDCs. The real value will be when CBDC interacts with DeFi, where the central bank actually provides collateral to stable coins. And so I'm hoping that's next, and I'm hoping they commit it in such a way that they're able to leverage DeFi composability, which is all the good stuff that Ethereum has and the whole crypto market has. When people say like, what is the use case for Ethereum, it often starts off with kind of speculative tokens of value and then transfers of value, and that's at first the Bitcoin model is limited supply reserve, being able to purchase and trade. And then off of that there was the ICO craze from the initial Slocket DAO, which showed fundraising, right? You can do an ERC20 fundraise, but the volatility led to the crypto winter crash of 2017, because more or less everyone that was on the Ethereum network thought it was like an open VC world. And so they did a bunch of OTC trading that did not comply to the Howey test of the securities that they were trading. And so off of those securities, they basically like rage quit the entire ecosystem so that they can go off and build for another 2 years. But I think through that, 2017 to 2018 time point, I would say that the creation of MakerDAO was huge, right? The creation of DAI off of the stable coin that has a collateral debt position contract inside of it was huge. The creation of borrow and lending through Compound, as well as centralized CeFi entities like BlockFi and Celsius, allowing you to borrow USDC off of Bitcoin or off of ETH. That was very, very useful for bootstrapping the network. Aave coming up with pretty much variable interest rates, right? And those returns were super useful. The idea of asset managers just being smart contracts was super cool with the SET protocol and people forking that open source code to create their own version of SET protocol, right? You can have a token that has a dollar value, has a percent distribution of existing tokens, and then you can just sell that as a fund. And that's also very, very cool, because then you can have a team like in the startup days, instead of having a bunch of creating a bank, you've basically created an asset manager in a few clicks almost. Then DEXs were ridiculously important in this kind of hierarchy and kind of overlay of composability. So early papers that we wrote about DEXs were about repeating an exchange, which is an order book matching system, and doing that on chain. And that was almost impossible to do because if you think about how order books work in exchanges, you have to do a bunch of manual matching. And when you do large trades, you basically have to combine a one-to-many, because if I'm buying like 1 million Bitcoin or $1 million worth of Bitcoin, I'm probably filling the order across a lot of parties. It's not just a one-to-one swap. And so the DEX original models was like, how do I, with very low code and no overhead, build a full order book execution engine on chain? And that was impossible to do. But Uniswap came up with pools, and like pooling is so cool. You're basically creating a pair, and with that pair, you're still basically using the same ideas of smart contracts, right? A smart contract, in my mind, is basically a delivery versus payment mechanism where my delivery is or my payment is the ETH, which has value. And then my delivery is putting my ETH locked up in that contract, saying that now I have, a row that on the cap table that says I have 10 of this new token. And so the locking up mechanism that exists in ERC20 that you saw from the ICO days still exists today and powers all of the patterns that you see in all of indexes and AMMs. That's all the same pattern, which is how do I send a transaction to a smart contract, lock up my ETH or my WETH or whatever you want to lock up, and then create as an outcome a way to receive dividends or a way to receive a new token that represents a new thing. So I'm going about this kind of very long way of saying that this journey has been quite exciting for someone that used to be in finance and now does DeFi and does a bunch of DAOs and whatnot. And I think that NFTs specifically in this space has brought in a lot more consumers. And I think the next phase of this will be an attention back to DAOs. And so DAOs being just self-organizing groups with a shared bank account, your DAOs are now collecting NFTs together. And now people are just buying into DAOs because that's kind of the ground of innovation. So instead of having an LLC, you may have a DAO, and that DAO may coordinate a bunch of work across different entities. And I actually just wrote, I was at MCon this week, and this is my website, but I just wrote a piece on 30 DAO patterns that I'm going to show right now for everyone if you want to read about it. Cool. And so that's what I mean by composability. I just talked about locking up locking up value into different protocols that call each other. New quote unquote financial primitives was just like a made up word, but the idea is Aave created a flash loan, and that was ridiculous because you can't do that. Even it's not even like, oh well, I created a structured product in 2 days because I wrote a smart contract that represents a complex legal structure, which, in the finance world took months to do and tons of resources to create a new structure. In the DeFi world, you're basically leveraging recipes across all of these different open protocols. And people often ask me, and I was asked this at Sibos as well, what is the difference between open banking API and like open banking version 2 or whatever they want to call it with DeFi? Is DeFi just open banking? And the answer is no, because open banking is still controlled by all the banks providing very strict API calls, and there might be some standard for it, but there's no comparison to an API call to an API call creates a new program. A user sending a transaction to a protocol smart contract and that contract calling 10 other contracts is crazy, right? It's like more open than anything else could be. And so, and maybe the best thing to do is to just tell you to try it out. DeFi Saver is how I learned about a lot of this, and the app itself shows you all these contract calls that are super interesting. This isn't my balance, it's a simulation. The simulation allows you to directly interact with the simulation chain, and maybe it's down right now, but you can see the transactions that you have to send to all of these different models, and you can see what transactions come out and how you can get balances. And so if you're interested in DeFi Saver, I'm sure there's a bunch of videos on YouTube of people walking through it. But the idea is all of these contracts are dApps, and all of these dApps are super smart, and they call a lot of data fields that are necessary to kind of create this whole market. The cool thing is like these recipe creators, if this then that fans know that they've probably gotten to this space as well, but you can do an if this then that, not between APIs, but between smart contract protocols. And so if I wanted to, for example, make a maker debt using Compound, I'm able to do that by combining these composable pieces of protocols together and creating a recipe of some sort. And these recipes are like centralized in some way because this DeFi Saver is putting them together for you, but you can call the contracts directly if you wanted to as well. Okay, last part is the technical concerns are addressed with L2s, which is performance, privacy, and reduced cost per transaction. So more and more parties are looking at public networks. And then the second one, and this is the hardest part, but it's slowly getting tackled through kind of legal structures, is how do I actually own ETH and make sure that it doesn't get, killed by regulations, and how do I rebalance my portfolio? And that's why I think ETH2 staking is so important to all of this, is because yes, you're kind of locking up funds, but if your fund has a consistent return, then you can sell that for a lot more money and fees. And so people have been kind of leveraging that. And just a final pitch, Consensus obviously has a lot of products and infrastructure. And we even have one called MetaMask Institutional, which is why my Firefox button is blue, is because I'm using MetaMask Institutional. The idea is it's the same as MetaMask, but it connects to a bunch of custodians. And so custodians that are going to be announced in the next few weeks will be able to use MetaMask and connect to swaps the same way as a regular consumer does. And so we're helping the institutional market get connected. There's other layers that we've added to it. So MetaMask Institutional also includes a compliance module. And it's a brilliant module. The way it keeps track of all of the addresses that have been either approved by or blacklisted by different areas, either through the dark web or just like through Etherscan, what the the Coinbase account is, what the smart contract addresses are. And then it creates a risk tolerance level for parties to execute their transactions off of these swap pools. And so it's super fascinating. Anyway, there's a ton that I can talk about. Obviously, I'm super passionate about this space, and the idea for migration of permission networks over to public networks is a fascinating and evolving thing to consider.
That was fantastic, Clemens. Thank you so much. We're kind of out of time. By the way, for the MetaMask Institutional, is that open beta or something like that? What's the status of that?
So we have integrations with custodians that are going to be announced, and we have a lot of early platform adopters that is going to be announced. I am beta testing it, and so I got like special access to it, but it is currently TBD. I mean, okay. It's going to be launched next month, but it's currently, I can't say too much more about it. I can say talk about the features, but I can't really like invite people to start using MetaMask Institutional.
Right, got it. Okay, now the 30 DAO patterns. I'd love for you to come back and go over them. It's on so we do have a DAO day where we got a couple of people come in and talk about DAOs. If you want during that day to come in and review, because I think DAOs are big deals now, right? And they're important, but it's still a big mystery, much like DeFi is to a lot of people. We know what DAOs are in general, but how do you actually do them and build them? And we know, Clemens, you and I know, because we're dealing with this stuff on a day-to-day basis, DAOs can be incredibly complex, right? And how you build them and how you structure them and the token economics behind them and all that. So whenever you feel like and I'm looking through your blog post here, and I shared it on Slack. It's some fantastic stuff there. If you ever want to come over to come back and talk about these 30 patterns, I'd love for you to do that.
Yeah, happy to. There,
Yeah.
I even have like I'm gonna present this to my internal team because they don't know it either. But essentially, how is this like pattern really a circle, right? DAOs led to ICOs, led to STOs, led to a bunch of DeFi patterns, led to NFTs, and now it's going back to DAOs. And I think that the maturity and the wrapping of all of these together will make it the next powerful pattern.
Yeah.
Anyway, well,
Yeah.
I will help present that. Feel free to send me an invite for it.
Sounds great. Okay. Without like, I don't think we have any more further questions. Clemens, thank you so much for your time spending. You're out in Denver early morning with us. Look forward to having you back. Clemens, you're going to post the two slide decks on Slack. If you can,
Yeah, I'll
post it there.
PDF it and then I'll just send it to Slack.
Perfect. We appreciate that. Thank you so much. The video of this will be out in a day or so. My staff that's going to process this is off today, but hopefully we can get it done by tomorrow or Monday morning at the latest. Thank you guys. Enjoy the rest of the weekend. Thank you for spending this part of your day with us. We'll see you at the next session, Tuesday, the 18th, I believe. 8 a.m. with Ave. Look forward to it. Thank you guys and goodbye.
Thank you.